Okay, good afternoon, everybody. First, I'd like to thank the Green Council for the invitation to share my topic with you this afternoon. I know it's been a long day, and it's always a challenge to hold people's attention in the afternoon after lunch or tea break. So I'll keep mine short and hopefully sharp. Now, most people understand the production of energy from fossil fuel, like coal, oil, gas. We'll talk about it quite a fair bit today. And also from renewable sources like hydro, solar, and wind. But not many people are familiar with producing energy from waste. Right, I'll first talk about waste, introduce how energy can be extracted from it, and how this energy could potentially be featured in our future energy mix, following trends in both the waste and the energy sector. First, I'd like to share a picture about waste. Now, MSW, okay, on municipal solid waste. Okay, normally we call it MSW. Normally it refers to the waste that we collect from residential, commercial, industrial establishment. And this picture shows plastic waste disposed of in a site in Maldives. So if you've been to Maldives the last few years, you potentially could have contributed to this. And according to a data shared by the World Bank Group, in 2016, the world has disposed of 2 billion tons of municipal solid waste. And if the current habit of our disposal continues, by the year 2050, we'll be producing close to 3.4 billion tons of MSW. Now in Hong Kong, according to the data from EPD, about 5.75 million tons of MSW was produced in 2017. And that works out to be about 182 kg per second, or 11 tons per minute. So by the time I finish this presentation, Hong Kong will have to deal with another 300 tons of municipal solid waste. Just to give you a few, one rubbish truck is 20 tons. So that's almost 15 rubbish trucks that we're talking about. So after my presentation, Hong Kong has created ways to free up maybe double the size of this room. That's how fast waste is being produced. So what happens to this waste and how do we deal with it? According to the same study, about 36.7% of the municipal solid waste were disposed of in dump sites. Okay, means were landfill. And 33% were in open dump site, means non-sanitary landfill. 13.5% recycled, 11% incinerated, and 5.5% composted. From these percentages, we're talking about disposing nearly 600 million tons of waste a year in an uncontrolled manner. Contamination of the environment around the dump site are serious causes for concern, and there are also conscious effort towards diverting waste away from landfill. Although sanitary landfills are better than dump sites, these normally occupy large tracts of land which can be used for other economic and commercial purposes. Now, data from the same study also shows that open dumps are more prevalent in low-income countries, where sanitary landfills are not yet available. Now, as a country advances economically, waste is normally managed using more sustainable methods. We observe higher recycling and incineration rate in higher-income countries and more landfill and open dump in the low-income countries. Now, I believe this is not difficult to understand. When you cannot feel the stomach, as what people say, you are definitely less concerned about keeping the environment clean. However, we should not ignore the fact that polluting our environment in the longer run will cost us more than what we believe we are saving today. So what can we do to deal with this huge amount of waste? Okay, let's take a look at the waste management hierarchy according to the Lansing ladder. Now, this waste management hierarchy indicates an order of preference for action to reduce and manage waste, named after a Dutch lecturer and politician at Lansing. And the first schematic version was introduced in 1979. So that's a good 40 years ago. Now, right at the top of the ladder is to reduce. So the best way to deal with waste is not to have it at all, right from the very beginning, which explains the current push towards zero waste. Now, if the item is already produced, then the next best alternate is to reuse it, if possible, or to recycle it into other useful materials. Now, to reuse is not always possible, sometimes due to damage or contamination. On the other hand, recycling is heavily dependent on technology available and economic viability. Now, lately, the last couple of years, because of the drop in commodity price and oil price, a lot of recycling has actually stopped because they cannot sell the recycled products and materials at the back end. So actually, a lot of our plants, we find a lot of plastics which could have been recycled coming to get it incinerated. Now, the next two steps on the lancing ladder is energy and incineration. Now, energy here refers to treating waste with energy recovery. For example, incineration with steam turbine generator, or composting with biogas recovery. Now, pure incineration refers to just burning waste without any energy recovery. Now, since our discussion today is about energy going into the future, my focus will be on incinerating waste with energy recovery, which I'll refer subsequently as waste to energy. So energy is a step below reduce, reuse, and recycle. According to the Oxford Dictionary, waste is something unwanted or unusable material, and the word residual refers to the leftover or remaining portion of something. So we refer to those items that cannot be reused or recycled as residual waste. It's a very commonly used term in Europe. And we put this residual waste to the next level of use, which is energy generation. Now, with current technology, residual waste can be converted to thermal and electrical energy pretty effectively and used alongside energy generated from fossil and renewable sources. We can also see from the ladder that landfill occupies the lowest position, mainly due to the environmental impact and little recovery that you can achieve from the waste. Now, with education, economic progress, and development, waste should be moved away from landfill and be treated by one of the methods higher up in the hierarchy where possible. Now, so under what circumstances is waste not considered waste? Okay, is when it can be put to meaningful use. Now, this picture shows a metal recovery yard, okay, where scrap metal can be recycled to steel products for the construction of new steel structure like this. I'm not sure whether you recognize this picture. This is actually the Kowloon station for the Guangzhou, Shenzhen, Hong Kong high-speed rail. Right, so all those scrap metals that we recover from recycling, after certain process, can be reused to build steel structure like this. Next picture. This slide shows the recovery of plastics. Okay, it can be recycled to pellet forms. Okay, and then this can be used as a raw material for new plastic products. So this is plastic recycling. Now, in these two cases, waste can be converted into useful resources. This one. This picture shows waste remaining as residual waste, okay, meaning that it's not reused nor recycled and has found its way to a huge landfill. I'm sure some of you will know about the Hong Kong landfill, okay, at the Twin Moon area. It's something similar to this, just that in Hong Kong there are some recovery and it's pretty well managed as a sanitary landfill. Now, as we have discussed earlier, we can convert residual waste to energy as an alternative to landfill. And as such, waste can be treated as an energy resource, similar to coal, gas, and oil that we've been talking about today. And this method of waste treatment also ranks higher than in the lancing ladder compared to landfill. There are also some other benefits that come from incinerating waste, apart from the energy recovery. Now, through the combustion, bottom ash is also produced due to the incineration process. Metal content in the waste can be recovered downstream from the ash and be recycled for other uses. So we can also recover metal inside. And with some further treatment, the bottom ash after the combustion can also be converted into various forms of aggregate for the use of road paving and sometimes as building material. So waste to energy is able to further recover resources in addition to the energy produced. Now, using this aggregate recovery is really quite common in Europe. Bottom ash has been used for road paving and some has been converted to aggregate for certain building types. Now, in fact, with is it showing properly? Okay, in fact, with various forms of recovery from the incineration process, waste to energy can arguably contribute towards a more circular economy, as illustrated by this chart. Now we start from the top, your left-hand corner. Okay, when residual waste is treated as waste to energy plant, the energy content of the waste is recovered for use. The process also reduced the waste volume by more than 90%, meaning that for every cubic meter of waste that you burn, the remaining ash occupy less than 10% of the original volume. So that saves a lot of space if you will need to landfill the ash, and is usually organically stable. The process also reduced the waste volume, yes, and then the ash, which is about 20-25% by mass of the original waste, can be further treated, okay, for the recovery of metals and aggregate, for reuse as a construction material, which I've just explained earlier. So when products made from these recovered resources end up as residual waste again, then it goes through the same process, making it circular. Of course, along the way, some things can get recovered, but some things will end its useful life and cannot be recycled anymore. To understand why waste to energy is a better form of waste treatment than landfill in the Lansing ladder, let's do a simple comparison. Now this table compares various characteristics of landfill and waste to energy. We see that energy is more commonly recovered by waste to energy as compared to landfill, okay, and occupies a smaller footprint in terms of land use space. And this is extremely important for cities with high population density and little land space. Example, Singapore and Hong Kong. Waste to energy also has a lower impact on the environment from pest, odor, and visual perspective. And if it's sited next to complementary industry, recovery of energy and other resources can also be more effective, okay, which normally does not exist for landfill. Given that Hong Kong is building its first waste to energy plant and spending great effort to promote the reuse and recycling, we are definitely moving up the Lansing ladder. Just a bit of publicity. So we are supplying the technology for this first waste to energy plant. Another advantage of waste to energy is the indirect greenhouse gas avoidance. Okay, we talked quite a fair bit about greenhouse gas today. So how does waste to energy as a process reduce the greenhouse gas? Now, the decomposition of organic material in landfill produces methane gas, now which is 20 to 30 times more potent as a greenhouse gas versus that of the carbon dioxide. We saw the possibility of recovering metals from the bottom ash after incineration, which could also save some carbon footprint as compared to the new material production. Due to the 30 to 50% biogenic content in MSW, part of the energy recovered from waste is also considered green energy. In fact, a lot of these waste to energy plants in Europe actually get green credits. Not as high as wind or solar, but it's definitely a credit to recognize the biogenic part. Now, having introduced how energy can be recovered from waste, now we can look at how the comparison of such energy is to the other form of energy resource that we talk about today. This table looks at the characteristic of waste to energy plants against other common power plants, driven by fossil fuel, renewables, and nuclear. A waste to energy plant is typically smaller in terms of power capacity, usually less than 100 megawatts. Plants are normally, it has an energy recovery and efficiency is usually lower. Okay, in some cases, quite comparable with most fossil and nuclear power plants. From this data, there's one thing that is very clear. We never built a waste to energy plant for energy. We built a waste to energy plant to deal with waste, and energy is a byproduct. You seldom hear someone say, we need energy here, let's build a waste to energy plant. Most of the time is we have all these waste to deal with, let's build an waste to energy plant, and then what can we do with the energy that's produced along the way? Usually if you have steam, it goes to industry around the area. If not, the power is used to supply to the household around the area. Now, from SOx, NOx, and dust emission angle, we see that the waste to energy plant generally has lower emission when compared to fossil fuel power plants. Of course, it cannot be compared to the zero emission for renewables and nuclear. but it's slightly cleaner. And as the standards of emission get more and more stringent, more effort will be put in for the flue gas cleaning, which we call scrubbing. So it's not a matter of how clean can the gas be. It's how much money you're prepared to scrub the upcoming. So that one, as technology improve, we can clean better and cheaper, and that will also help the emission of such plants. From greenhouse gas perspective, this chart shows that the life cycle greenhouse gas emission of a waste-to-energy plant per kilowatt-hour electrical is lower than that of fossil fuel, but higher than that of renewable and dedicated biomass. Now let's look at some of the energy trend. I think my two charts is quite simple as compared to those that have been shared with all the distinguished speakers today, but they're generally concluding the same thing and in the same direction. Going forward, we expect cost of renewable energy to trend downwards, driven very much by wider adoption and technological advancement. I think these things is sure to happen. In fact, some of the solar and wind installation have already reached grid parity, meaning that it's comparable to fossil fuel plants. Now, due to the inconsistency of renewable energy or intermittency, storage systems like batteries, integrated hydros are also getting more attention and development. This chart shows an increase in the use of electrical energy across major global economies. The electrification, I think this one is everybody will using more and more. So it's not carbon footprint, it's your electrical footprint. Everybody is using more and more electricity. So we have electrification of our transportation system, wider adoption of electronic products. I think the very first chart that Felix showed in the morning, instead of using a broom, you use a vacuum cleaner. Instead of hanging your clothes to dry, you use a dryer. So all these things create a new need for electrical energy. Okay, communication, data transmission and storage. Now, some of you might be aware or not aware, but because of all those things they are pushing to the cloud, the world is building at very, very fast speed data centers. And these are huge energy consumer. Okay, so we keep using, and then they keep producing. Just that you don't see it most of the time. Now, with growing concern over climate change, a big topic today, the push for the lower greenhouse gas emission, this 1.52 degree target, and potentially cheaper energy from renewable sources, we also expected to see higher share of electrical energy generated from renewable sources in our future energy mix. So that's the projection. So, what role does waste to energy have in the future? Okay, we can try to answer this question by analyzing development in both the waste and the energy sector. Now, in our effort to reduce, reuse, and recycle, if they do not take a significant improvement, then the amount of residual waste that needs to be treated will be a big challenge, like many cities, 3.4 billion tons by 2050. Now, landfill diversion could also increase the need for waste to energy as a form of residual waste treatment. Advancement in the waste to energy technology, particularly in energy efficiency, as well as material recovery, could also drive wider adoption of WTE plants. Now, on the energy side, with the push for greener energy and more emission control on power plants, waste to energy plant could continue to be featured in the energy mix going forward if waste to energy remain one of the selected methods for waste treatment. Now, to conclude, recovering energy from waste to energy is largely dependent on our future waste trend. So if the world achieves zero waste, this is what we have been pushing for, then waste to energy will not exist at all. I'll be out of job. Okay? Now, on the other hand, with improved technology and the persistent waste habit of human mankind, waste to energy could be very relevant going forward if there's more and more waste to treat. So which scenario will prevail? I shall let you decide, because it's ultimately driven by your behavior. Thank you.
Since Mr. Jackson Goh has to leave early today, does the floor have any questions? Do you have a question? Well, one question.
Jackson, will you? I know that you are going to build a incineration plant for Hong Kong. Do you have some update for the audience, the progress?
Okay, there's a plan to be built just to the south of Seghers Island, and currently because there's island to be reclaimed, so it's pretty much the marine work that's ongoing. Yeah, so we are also doing some early design and procurement works. Yeah, but on the site itself is purely marine works at the moment.
If you look at incineration in Europe, then more and more incineration plants are combined with separation plants. To have, because you showed the matrix, for example, for plastics or those kind of things. Do you plan to incorporate that as well in here in Hong Kong?
Yeah, in Hong Kong there is a requirement to have this sorting plant at the front. So it's a 3,000 ton, but at the front there's about 200 tons of sorting at the front. So around the world, we are seeing more and more such practices to have sorting at the front before the burning at the back. So you try to recover those things that you can recycle. So it's a trend as well.
Any last questions? All right, thank you, Mr. Goh.